All right. So today we're going to talk about an update about OCP attestation, what happened. So we start from the journey we made it from Dublin. We presented the first OCP attestation update a few months ago in Dublin. We presented the need that was for a need profile that was not there back then. And we made a long journey since then, and we developed the first complete draft, because right now it's a complete draft of the e-profile, and we are looking for review. And we created the first device identity provision spec draft, which is still available for review. So, and both are in the OCP security GitHub for review, and we invite everyone to look it up. So I give my word to Roksana.
Thank you so much. Actually, the purpose of our working group and our proposal is, as everybody knows, in the industry, we have a dilemma that every SOC vendor, they have their own format for the platform attestation and confidential computing attestation. And that's why, because of this fragmentation of the evidence format, it's very hard for CSPs and verifier to verify every different format that SOC vendors are offering for their attestation. And because of that, the verifier needs to have a custom parser for each silicon vendor, and they cannot reuse that code at all. The other parties, they need to integrate for months these different type of format of the attestation. At the same time, validation takes a lot of time, and it's not easy for verifier and SOC and cloud provider to be able to verify any attestation format at this point of time. What we are proposing, the other way. What we are posing that, okay, we are looking for a standardization of this single format of the evidence, that everybody of the SOC vendors would use that format for their evidence. And the base of the fundamental of this format is well known to everybody. It's coming from the ITF 8 and from RFC 9711. It's based on the RAT architecture, nothing new, but we are actually making that one some sort compatible and comfortable for every silicon vendors to use it. With this approach, actually, we are starting to adopt this one in Calipro. Calipro is early adopter for this OCP profiling. And we do have a demo, actually, which I'm going to talk later in our booth in Microsoft if you like to join and see the format. And with this approach, we are making all the SOC vendors to be truly interoperable, and everything works seemingly as it is and make the life easier for verifier. With that said, I'm going to hand out to Fabrizio, yes.
So let's discuss about this e-profile. What is about? Like, there is the core of the e-profile we developed is about the concise evidence. Whoever is familiar with the TCG SPDM concise evidence specification, we integrated this into this profile. Why we went to that direction? Why we integrated the concise evidence? What's great about the concise evidence? So the idea of the concise evidence was to create the evidence in the same format as the quorum, because concise evidence use the same semantic as the quorum. So we use the target environment definition, which has environment map and measurement map, which whoever is familiar to develop a quorum will be using the same. So since the RATS attestation specification require a quorum as a manifest for both reference measurement, for conveying both reference measurement and endorsement, we said, why not using the same format also for the evidence? This way, a verifier will need to use the same code to basically verify, to basically make sense of what comes from the device and what comes from the reference measurements. And this one-to-one mapping between evidence and the reference measurement in the quorum will simplify things, because we saw a lot of stuff like in the past, for example, when people use a traditional SPDM measurement block, use a measurement block 1, 2, 3, 4, 5, 6, 7. But what they mean, these blocks, like they need to have a specific like translator. They will basically map measurement 1 to this bootloader, measurement 2 this operating system. And this will be specific from vendor to vendor. Now, with this concise evidence, we are basically using the same exact semantic for describing the evidence as we define the reference measurement. So it's just a natural way to describe this. And going to the next slide, for example, we can see how the reference measurement works. So this is our READ profile. You have a profile name, which is an OID that OCP will assign once the specification will become, once the draft will become a specification. Then you have a nonce for anti-replay, an issuer which will tell who assigned the EAT token. And inside, like whoever is familiar with the EAT, there is this measurement block, which EAT main spec made it open-ended because it can be, the measurement is just a placeholder to put the measurements. Like if in our profile, our measurement is encapsulating the concise evidence. And the concise evidence, as we can see in the data structure here, there is a class, so an environment map, which has, for example, bootloader, firmware, operating system. And then there is, in the same structure, the actual measurements, which can be digest, SVN, firmware version, and whatever other things that will make sense to describe the security posture of the particular component. So as we say, and I keep repeating myself, that the key innovation of this is being able to use the same triple format for both quorum and the evidence, because the same concise evidence structure, whoever is familiar with CBOR diagnostic, for example, because the CBOR is not human readable, the diagnostic format is human readable, is exactly the same. So you have the same way to visualize your claims. So what do we just cover right now? We say that we have an OCP profile, a single evidence format, and a simplified verification. Now, the next challenge we have right now is how the key decides, how to verify that the key decides the evidence is trusted. Because everything can sign the attestation evidence, but how can verify that the key is trusted? We've been going like, so there are multiple ways, like there is always an endorsement chain, sometimes they come from the vendor, but for some multiple reasons, this may be not trusted by the verifier. And so now I will end the conversation to Jeff, which will continue to describe this problem.
It's probably sick of me by now. All right, we are posed with a PKI problem, which is really an opportunity of how to improve things. So this is a dice chain. It looks like the Calyptra dice chain. There are other devices which have slightly differently shaped dice chains, but we're going to look at this one just because we're familiar with it. These have different measurements. We discussed in one of the talks earlier what kind of data goes into creating each of these keys. You got UDS, field entropy, some tenant configuration like the first mutable code signing key, et cetera, and the measurements thereof. We also have a certificate over the IDEV-ID root key. This is very natural to do. This is how we track devices as they go across the supply chain. Once the device is deployed, if this remains how things look, then every time you're verifying attestation, you will route back to a vendor PKI, not one vendor PKI, but all the vendor PKIs, because a lot of vendors are making parts these days. And if one of those vendors has a breach in their PKI, if they lose control of a signing key, then the downstream users of our devices are now at risk. So there's motivation to supplant that certificate with one issued by someone else, like the cloud service provider, sometimes called the owner. I'm going to pause here, by the way, and say I think we have a naming problem in this area. In the last few days, I've used the word owner to describe at least 4 different things that are all not the same. So we got to clean that up. But here I'm talking about owner being, I am the CSP, it's my device, I want to label it as such. I'm going to issue a certificate over the device. And now I want all attestation to go through that PKI, mine, and not the vendors. Now you can get that property by taking your certificate and stapling it onto IDEV-ID, just co-signing it. Say it was the vendor's IDEV-ID, now it's mine. But here we're illustrating something a little bit different. The owner certificate is actually attached to a different key in the hierarchy, LDEV-ID. Remember earlier in Calyptra, in one of the Calyptra talks, we were talking about why field entropy, so that you can program it at the data center. And so someone in the middle of the supply chain who knows UDS does not know field entropy. In such a threat model, someone who knows IDEV-ID, knows UDS, if you staple your certificate onto IDEV-ID, you haven't really solved anything, because the adversary who knows UDS can just know the IDEV-ID key and go off and do whatever they want. So by stapling owner certificate to one layer beneath, you are saying, no, I want to staple to the key that is only derived from field entropy. Similarly, you can imagine a tenant might want to come in and say, hey, I want to put in some configuration, make the DISE alias key look the way I want it to look, have my measurements reflected there. And by stapling a certificate at that layer, you can be confident that as long as attestation is working, going through to my certificate, I don't need to be rechecking that the tenant configuration is still what I wanted it to be. It's by definition the same because the key is still usable. If the configuration changes, the key is not there anymore, and the certificate is just so much data. So, right, we isolate certificates from vendor PKI compromise, and we bind each certificate to different device characteristics. So this is the capability we want to see. APIs don't exist for this right now. How to get certificates from different layers of the DISE chain to know what kind of certificate you're getting, right? Like, this is a Calyptra-shaped DISE chain. It's not going to look the same for all the devices. So how do we come up with some standard way to express, here are the ingredients that went into a particular key in my hierarchy, so that as a CSP, we can target the ones we want. Commensurately, there's a problem with CSRs. If you want to take a key from anywhere and pass it off to get a certificate over it, you typically need to turn it into a CSR. And CSRs are typically self-signed. This provides proof that the key could be used to sign itself, which is nice, but is not really what we want in our environments. I want freshness, and I want proof that the key was held by a device that I trust. In addition, not all keys in a DISE chain can actually be used to create self-signed CSRs. Like if it's a DISE key early on, it just signs the next key and moves on, and it's also in hardware, so I can't patch it now. So the solution which we are coming to is defining a signed envelope, a standard conveyance format for, there's a CSR. It might or might not be self-signed. It doesn't matter because it's envelope signed by a key that we can wield at runtime. It provides evidence of which key or which device emitted that CSR. We can include derivation attributes, so you know what ingredients went into that key, so you know which key you want when you're issuing a certificate, and freshness nonce as well. This is all under construction at this repo, where we are defining the formats and commands to interact with the device to get this stuff. So come on to the OCP security project and help us out.
Just to wrap up, we do have actually a coercive attestation demo at the Microsoft booth. If you guys are interested to join, that would be great. We are showing what at the end result, the whole thing bind together. We do have the evidence from the attester, and we do, that evidence from attester would come in OCP EAT format, and we do have the quorum for the reference and evidence that we can actually match our evidence to make sure that, okay, the measurement we are getting from the OCP EAT actually match with what silicon vendors and SoC vendors already put together. This approach would make the life of the verifier way easier. And at the end, we do have the endorsement from the OCP third-party auditors, that safe OCP, which we are doing. Sorry, I went so quickly. But we are making everything work together, and then at the end we are going to give the appraisal result to the customers, which will be able to see the beauty of all these approach together. And this would be a unified approach across all the SoC vendors, and there is no discrepancy anymore between the associated vendors if we follow. And if you go to the Microsoft booth, you will see our demo. And call to action, we are looking forward to standardize the attestation format. And we want everybody, all of you guys, to join us in our OCP security working group on Tuesday at 9. We already put together the document. It's live. We appreciate your feedback and let us know how we can actually improve it and how we can work together to make this issue which we have across the industry solved. Thank you.
So I have a question. Maybe this was answered indirectly on the slide with the PKI opportunity, chain of certificates. Let's say if one is using the Calyptra open source RTL, does the hash of that RTL would be attested or certified or verified by some chip alliance hosted CA server or something? Is there such a thing, or it would be?
That's really taken care of before you tape out and ship your product. You get someone to sign off that you actually integrated properly, and then your IDEV-ID certs are essentially you endorsing, hey, this is a product that I made that has Calyptra, and someone signed off on that.
So the ultimate vendor signing it, that's where the chain would stop.
Yep.
It would not chain back to Chip Alliance or anywhere else.
Correct.
All right.
All right, we are up on time for questions. I'm sorry, but we can maybe take them outside. We're going to go into a break, but I know they're going to stop the recording and stuff. So, thanks a lot.